Hello, my name is Agnes Leroy. I am GPU director at Zama, and today I will introduce you a new feature in TFHE-rs v1.1 that allows you to select for every encrypted operation on which GPU you want this operation to happen. Basically, this gives much better throughput on machines that have multiple GPUs available. This is what we're going to see today. So up to version 1.0, there was nothing to do for the user to execute on multiple GPUs. So before, the only way to use the multiple GPUs was basically that TFHE-rs would deal with it automatically, meaning that the server keys would get copied to all the GPUs, and the logic for how the work is split on the multiple GPUs is embedded in TFHE-rs. Unfortunately, for many operations that are not so computationally intensive, for example, 64-bit additions or subtractions, this is not the best possible solution when you have many encrypted operations to perform in parallel on the GPUs. Then, now, starting from TFHE-rs v1.1, we added a new possibility to select on which GPU the operations happen. So, you can define manually where the server key is located, so on which GPU. So you can actually create a vector of server keys with one key per GPU, and then you can select for every batch that you're executing on which GPU you want it to happen by setting the server key to that specific server. Okay, so let's see an example in the code. I'm going to take the same example I had taken in a previous feature video of TFHE-rs, which is an encrypted memory money transfer, where the amounts we are transferring from and to are encrypted, and also the actual amount we are transferring is encrypted. We are operating on 64-bit integers, and we are going to be performing 10 transfers per GPU in parallel. So we have 8 GPUs on this machine, which means we're going to be performing 80 money transfers in parallel on all the GPUs. So here you can see my machine has 8 H100 GPUs. So the H100 GPU is maybe not the most powerful one now because there's H200 GPUs, but still it's one of the most high-end GPUs from NVIDIA. And we have 8 on this particular machine. So if we execute the code, as it can be written up till version 1.1, which means we don't do anything. We just decompress the server key without doing anything particular, which will copy it to all the GPUs. And then we write a parallel iterator on all our amounts that we want to transfer from, to transfer to, and the amounts we want to transfer. And we perform the encrypted transfer. If we do this, you can see that to execute those 80 transfers in parallel takes about 3 seconds on the 8 GPU machine. Now, what we can do, starting from TFHE-rs 1.1, is to write things differently. So actually, you can find all the details for how to do this in the TFHE-rs documentation for GPU. The main idea is that now, instead of having only one server key, you will have a vector of server keys. And in each component of the vector, you store the server key for a specific GPU by using this new function, decompress to specific GPU. And then what you can do is, instead of writing a par iter function as you would do in the previous example, here you can write par chunks. So this means you want to execute in parallel on chunks of the data with every chunk, the total number of transfers divided by the total number of GPUs. You can go even further than that by defining a number of streams to be used per GPU, and you can check all of this in the TFHE-rs dedicated page in the documentation. Now, if we execute this second way of writing the execution of a batch of 80 encrypted transfers on 64-bit data on 8 GPUs, you can see that we can go down to 1 second for the execution, which is much better. It means we have increased the throughput a lot by using this new feature in TFHE-rs v1.1. Thank you very much for listening. I hope this will be useful for you, and see you in the next TFHE-rs feature video. Bye.